You're listening to the Australian Water Association podcast series.
I'm Ellen Fanning and I'm joined by Zoubir Ait Mansour. Zoubir is Suez Water Asset Manager for Australia and New Zealand, and he's talking with me today about a paper entitled A Practical Approach to Balancing Risk and Cost, Unitywater Sewage Treatment Plant Assessment. Thanks so much for joining us, Zoubir.
Thanks for having me, Ellen.
Take me through this assessment project. What was the main objective of the project?
So the main objective of the project, initiated by Unitywater, was to conduct an assessment that would enable improving the reliability and the availability of their sewage treatment plant in the Sunshine Coast. So that was one of their strategic goals. So this project was intended to help them achieve that.
And you note in the paper that reliability and availability were very much the goal of the project, but you were also looking at cost, weren't you?
Yeah, definitely. Actually, behind reliability and availability, the overall objective of this exercise was really to help them mitigate risks, mainly compliance risk, and identify opportunities to reduce their cost, their total cost. So risks and costs were pretty much the high level objectives for this project.
So first of all, take me through the scope of the assessment, because there's 11 sewage treatment plants in total. So that's quite a lot of assessment to do. What was the scope of it?
Yeah, so actually, we've ended up conducting the assessment on 14 treatment plants, but at the time of the paper, we had completed 11. So 11 sewage treatment plants in the Sunshine Coast, all with different size, different technologies, different age.
So let's go through the detail of that. You start by talking about the approach to asset failure risk assessment. So obviously risk control, efficiency are really important inputs for establishing those priorities and making those optimal decisions you're talking about. What was the methodology that you used to assess that risk, and how was it expressed?
That is a good question. Actually, asset failure risk is really the cornerstone of any asset management decision. Everything starts with risk. So for that particular project, the risk we've assessed with Unitywater's teams was the risk of asset failing. So we've been through the list of their assets, asking ourselves what would happen if this function was lost due to a failure. So risk is composed of likelihood and severity. Both are important. So the first thing was to try to understand what would be the impact of the asset failure in terms of health and safety, environment regulation, water treatment, and cost. So these were the criteria. And we've tried also to assess the likelihood of the failure based on historical data from their asset management information system. But more than that, based on their operators' experience. So we have a model, a practical model that is called SIFMECA, that was developed by Suez. It's a methodology that is particularly adapted for the water industry. It is a simplified version of the famous FMECA that is used in all sorts of industries worldwide. So this is a simplified method that is easier and faster to implement than the FMECA. And one interesting aspect of this methodology is it enables us to express the risk in dollar value, and that is quite useful to be able to compare risk and cost. And as you may know, yeah, one of the main driver of any good asset management decision is really risk and cost. These are the two main drivers of any good asset management decision. So basically that's how this particular methodology of asset failure risk assessment works.
So as a first step, that's pretty significant, isn't it? That with limited time and effort, you can have this methodology based on failure modes and critical analysis methodology that's adapted to the water industry that can give you an expression as dollars of what a risk looks like. I mean, that's a very valuable tool.
Yes, it is indeed, and we use that tool in all our plants worldwide, and it is extremely useful for many different purposes. The outcome from this risk assessment, is really valuable in itself, even without the condition and the project's prioritization we've done after that. It has really value in itself to help asset managers make better decisions. So that assessment can feed many different processes. It can help make decisions regarding critical spare parts. It can drive preventative maintenance optimizations. It can help prioritize renewals and improvement projects. It can also be useful to justify some projects to feed some business case, the business case process. So yeah, there's a lot of things we can do with the outcome of this asset failure risk assessment. Definitely, that is an extremely valuable outcome. And an important aspect of that is that this is really this process really requires to work closely with the operation and maintenance people. So we've done that with Unitywater's O&M staff, and we've been lucky because Unitywater have very knowledgeable and very experienced technicians and operators in their plants. And usually the more experienced and the more knowledgeable the O&M staff, the better the outcome. So with Unitywater's team, we have been really lucky, and we had great people, and that led to a very high quality outcome.
And to what extent then, once you have that sort of information about risk, does that really drive your approach to asset condition assessment? Because you write in the paper, all right, well, a risk-based approach means you can focus obviously on the assets with the highest risks, but you can also use that data, surely, as you describe, to get this sort of multi-level approach where the higher the risk, that drives a more detailed assessment. So it drives the next level of what you're doing.
Yes, indeed. Actually, the risk is an important input to define your asset condition monitoring plan. The thing with condition monitoring is it has a cost, actually, and condition assessment can be an expensive thing to do, as any utility knows too well. So the key to get value from any condition assessment is really to be able to distinguish assets that deserve being monitored in terms of condition closely from assets that don't really matter. Low risk assets, low value assets that are not worth the cost of condition assessment. So asset failure risk helps us make that distinction, and helps us identify the different level of condition assessment to apply to any asset. Some assets might not deserve to be monitored at all because the risk of the failure would be extremely low. It would, for example, have no impact whatsoever to the operation and be an inexpensive repair. So in that case, we might not spend our limited resources in trying to monitor the condition of these low risk, low value assets. At the opposite, you can have high risk, high value assets that would deserve a lot of attention, maybe even continuous monitoring, to try to detect any deviation from their normal condition and try to prevent failures and try to plan projects before the condition gets too bad.
And finally, you sort of list the project prioritization, health and safety being at the top, second priority being compliance, and the third priority being efficiency to reduce life cycle costs. But what was interesting was obviously within a given category, you're going to have to prioritize individual projects, and you came up with a value for money ratio for doing that. Just talk us through that.
The value is really in the decisions we are making with this data, and condition and risk assessment is valuable to identify risks and opportunities that needs to be addressed. So in that case, we've identified something like close to 200 actions and projects to address risks and opportunities, and we had to come up with a process to prioritize. We couldn't start all these projects at the same time. So as you said, the first criteria was the type of project. So we've divided the projects into 3 categories depending on their main purpose. The highest priorities were given to the health and safety risks that were above tolerance. Then we had the compliance, which is mainly water treatment, water quality, risk of non-compliant discharge. And the third type of project was the efficiency project. So these were projects that were meant to address issues that didn't present any risk to water treatment, to compliance or health and safety, but where we detected an opportunity to make savings, to reduce the TOTEX, the life cycle cost of the asset. So this value for money ratio, as we've discussed before, the ability to express the risk in dollar value opens the door to be able to simply compare risks and costs in the same equation. So this value for money ratio would look at the project expected impact on the compliance risk expressed in dollars per year, plus the expected project impact on the TOTEX of the asset, on the annualized TOTEX, also expressed in dollar per year. So the sum of these 2 expected impact would be then divided by the capex required to implement the project, and that is the value for money ratio. That really gives you a sense of how much value do you get for each dollar invested in the project, and the value there is risk reduction and efficiency. So that's what this indicative value for money ratio gives us.
Wonderful. That's a fascinating way to make sense of all that complexity and allow utility managers to really make optimal decisions, about reliability, availability, compliance and cost. Thank you so much for taking us through the detail. Zoubir Ait Mansour is Suez Water's Asset Manager for Australia and New Zealand. Thank you so much.
Thank you.